My talk is going to be a beginner's talk this time. Last time we went more into depth, but now I want to talk about things that happen to newbies actually quite a lot. And is that full screen? Yeah. And I think it could be helpful for those, especially those switching languages and coming to Go for the first time, to understand. What's the headline? Go is pass by value. So whenever you call a function or you use the range parameter or whatever, it's always pass by value. And this is actually many languages follow that paradigm, but I think not many languages have it implemented as well as Go has. And therefore, people are actually used to faulty behavior and have difficulty adapting to it in Go. Ooh, it's not working yet. Sorry. I really want to use that clicker. There we go. Credits. Thanks, Janus, once again for sponsoring. Thanks, We Accelerate, for letting us be here. That's really a great opportunity, especially with Sector 5 breaking off. And thanks, Robert, for usually organizing this, and I'm pretty sad that he's not here today. Myself, I'm a software developer for actually at least 10 years, and I'm doing Golang nowadays and do a lot of Perl and TypeScript. I used to be a sys, that's actually the slides from my last talk at a different venue, so I had to talk more about my sysadmin experience, but it matches your requirements. I've done that 15 years, and for, I don't know, installations of 20,000 users and more. And I'm an expert still at causing and fixing disasters. And if you are interested in what I tweet, just follow my Twitter handle. It's quite easy to remember. And my email address, if you don't remember my Twitter. This is a beginner's talk, and it's about Go passing everything strictly by value. If you have questions, I can't recall, but I think there was a reason last time that you couldn't ask me questions during the talk, because I think it's due to the recording. So ask questions after the talk has something to do with the recording. What is passed by value? All parameters are always passed as values. There's two paradigms. The one is passed by reference, and the one is passed by value. And if you pass by value, or if you pass by reference, it's easier to explain. The calling and the callee function actually share the same variable. And so whatever you do to the value in that variable happens on both sides, to the calling and the callee side. And people got quite used to that in some languages like JavaScript, Perl, Python. And so it's hard to see that the Go follows it. Actually, the same. All languages say they do pass by value, but not all behave that way. And so I want to talk about the details in this talk. Let's start with the examples. We have a struct example here. It's quite easy. We have a skill struct, we have a person struct, and we have a, can you read all that? Is it big enough? And we have a very simple main function, and it's just, okay, what is this? What is it going to print? Output is going to be Koki has a painting skill of 2, which is an exaggeration because I can't paint at all. And but this is just the introduction with the struct we are going to work on. So we have person with name and skill. We have a skill, and we have some main function working with that. So now we want to increase the skill, and this is what happens quite a lot. We have a function, and we have a receiving type that can call increase skill. And so we construct our person and say increase skill, and what is it going to print? And for those who are new to the language, they might be astonished that actually from print line is going to print 2. So what is happening? We are constructing a person. We are actually passing that person into the increase skill function, and we're incrementing the level, printing, and it says, okay, your skill is now 3, which is increased. But when we call print line for the calling or in the calling function, we reduce to 2 again. And this is the basic idea of pass by value. We copied all the values of person into the function, did something here, and the calling function doesn't know anything because they are not sharing the values or the variables, sorry. Okay, so what can we do to fix this problem? We can pass in a pointer to person, which is probably what most people do, and it's not a bad way. I'm going to show another way as well. So we're constructing the person, cookie skill is painting, this notation as well. And we say increase skill once again. We increment the level, and now what we are passing into the function, we're not passing the struct itself, but a pointer to that struct. So what is happening, the pointer is also copied by value, but the pointer is pointing to an address of the original struct. So keep that in mind. We're actually dereferencing and copying the value of the pointer. So now the output is as expected, painting 3, painting 3. There's an alternative way to do it, and you have to decide, depending on the situation, what you prefer, is to have a receiving function, p person, increase skill person. If you like chaining, for example, then this would be, so this function, because you're looking a bit astonished, we have a function that's called onPerson, called increase skill, that returns a person. Okay? So what we do is we actually copy this person into here, and then we increase the level of this new variable, and we return this new struct. Okay? So this whole thing only works because I'm saying p equals. So I'm reassigning p to my old p. And now printline also says painting is 3. Yes, questions after the talk, but ask now.
And so we see that we have a copy in the
yes.
We don't use pointers, it does copy go. But, so you also pass the skill in when you create the person.
Skill is part of
it's another struct.
It is another struct, but it's also copied.
Yeah.
Okay.
So it's a deep copy. Right?
It's a deep copy, yeah.
I just want to.
Yeah. It's a deep copy, but of course I could have implemented the struct as having skill being a pointer to something. Yeah. So in the type definition, you can say, is it skill, the type skill, or is it a pointer type skill?
Okay, but would it then
that would have been in the initial slide.
Yeah.
Here. Then I would have said skill is asterisk skill.
But if it was a pointer, would it then, if I increase the level of the skill,
wouldn't make a difference in
the person to the function, would it do a deep copy, or as it is a pointer?
Wouldn't have made a difference because we are copying that person struct. Okay, because it's not the when you copy you copy. I mean. Okay, you think you said that it's a pointer. Yes, then I would have dereferenced that pointer struct. Yeah.
So it would be the same.
It would have been the same. Yeah, it would have dereferenced the skill.
And it would have increased the level of the skill.
Yes, correct.
And it would have worked like.
Yeah, but be careful with those structs. Yeah.
Okay.
Yes. Okay. Good. So. Okay, now I explained that the basic thing, and now let's that's the question, which one is going to work, okay? So we're in our func main, and we have a person. I still have the painting skill of 2, and now what do? We have a p equals p set name a, Hannes. And so what is going to happen when we are here in this print line fun? Anyone? So what do you think are we going to print? You can make mistakes or just guesses, or well, let's do it the other way around. Who thinks we are going to return cookie or print out cookie? Nobody, okay. Who thinks that we are going to print out Hannes? Yeah, good, okay. Set name B, what's going to happen? So set name B is being called after that, so we are at Hannes now, and now we're setting Gertrud. What are we going to have printed in the next line? Are we going to have Hannes, or are we going to have Gertrud? Sorry? Hannes, correct, because we are only changing the copy's value, okay? And set name C, Bella? Bella, okay, very good. And for the newcomers also, quite good to know, and it's quite useful in Go. If you have a pointer receiver, then you can still access the fields by just accessing them. So you don't need, you could, but you don't need to dereference the receiving struct and just set it, and Go does that for you. So I've seen this being criticized. I actually love that feature. Okay, did we say this? I hope we did. Okay, so the second example I want to give is for slices. And I think slices are really the implementation where you see that the effect of that copy by value. And I don't know if you all know the difference between array and slice. And so this is how you define an array. An array has a fixed size. You know exactly how many elements something has. And a slice has, a slice is actually a struct pointing to an underlying array, and does not define the length of the array by itself. You initiate a slice with the make function, so a nil slice is always useless, and you can't work with it unless you append to it. But then append actually creates an array, and the slice has the advantage that you can append to it, and you can use slicing on it, and so it's the useful implementation of array. Array is very performing, but slices are actually what you see in the wild. And the important thing to note here is that slice is let's call it a struct with a pointer to an array with the information of length and capacity. So length is how many values we have actually used from that array. Capacity is how big the underlying array is. So how many more values could we just add to the underlying array without doing additional work like increasing the array, assigning another array. So our example, again, person, but a simplified person. It's not so important what the person can do with just a name field. And we have data is a slice of person with Frank, Doris, and Beat. Okay, I think that's a Swiss name. And when we print that, we get this result. Okay. We already know the deal from our first example, from the struct example. And so let's just return a person slice. We learned that before. That always works, right? So what do? We have data equals modify slice returns a slice of person, wonderful. And we have data, we range over data. Everybody knows the range. So range can go through slices and maps and stuff, and returns an index and the element, the copy of the element itself. But I told you the solution already. And we say if pname equals the search parameter, then replace pname with the replacing, so these are both strings. So we want to find Frank and replace it by Torin. And our initial data array, you remember, is Frank, Doris, Beat. And the output is Frank, Doris, Beat. What happened? What happened here is we say range data, and so we go through each person. Range copies the value of the element, and if we change name in here, we're actually changing the name of a copied element, and we're not changing the name of the underlying array. And this is actually code that I found 2 weeks ago in our code base, which is advanced. So it happens, especially when you switch languages. This does nothing. Okay, I mean, it burns CPU cycles. It does something. So, okay, it is copied by value, especially be careful with range. And so let's fix that. Okay, we can, the construct of actually returning a slice wasn't bad. What we can do is for IP, so I is an index, P is the copied, I wouldn't usually write it this way probably, but I did now for making it more clear. We range over data and say if pname equals the search parameter, then change data I, so the index of data name, to the replace string. So why is this working? Because we copied data in here, and data is a slice. It's not the array. So we didn't spread the array, but we are actually copying the slice, which is a descriptor to what we said. It's pointing to an array. It has the value of length and capacity. So this is what we copied. We didn't copy the underlying array. We just copied the descripting thing. And we return data, and modify slice is actually going to be, as expected, Torin, Doris, Beat. Is that clear? Okay. What would happen if we do not assign it to our data? So we have the same function, modify slice. And from main, we call the same function, but we do not assign it to data again. What is going to be printed?
If I can guess.
Yeah, of course.
Slice.
It's a question. You have to.
Slice is a pointer to the original array.
Yes.
So if we change
Yeah.
the values, I would guess.
Yeah.
They should change because it's a pointer.
You are correct. Okay, but this is unexpected when you don't think about what you are actually passing.
Yes.
It is correct what you're saying, because we are still working on the same array. Right, it was the pointer, and we changed the pointer's value of element whatever, the one that matched. Okay, but this is we're getting to the next example. Why this is important to notice. Okay, so why is Go behaving that way? It's a question. Like in JavaScript, it's so easy. I just pass an array and I say array push, and it pushes to that array. And if I return, I get the same array. And if the calling function has this, so callee and caller have the same thing. Okay, we said it was passed by value, and slice is not the array. Slice is pointing to an array, and this is, I think this is the main thing I want to tell you actually in this talk. So it's a descriptor for a segment of an array. a slice, okay? And another important thing to mention is one array can have many slices pointing to it, and they can actually be mixed, so you can have an array of 10 elements, and you can have a slice taking the first 3 elements and another slice taking all 10 elements, and you can have another slice just taking the last 3 elements. So you have to be very cautious what you do with your underlying data structures. And all descriptors are pointing to the same array, so even if you do slicing of a slice, you have to be careful. Are you doing lazy slicing, or are you actually really copying the values of the underlying array into a new array? I think I'll show you another example of that later. And yeah, a slice is only a pointer, capacity, and length. And the actually data is being held in the array. Okay, so sounds easy, but, and this is again the questionnaire part. And so we have another function called append to slice, and okay, we found that pattern somehow useful. We're returning a slice that somehow worked for us in the past, and we're doing 2 things. So first, we're passing Kim name, and we're actually appending Kim to data. And what we're also doing is, I mean, this is a bit dangerous because we can't know that the slice has more than one element, but for the sake of this example, I think it's not important. And we're actually assigning new name to the second element in the slice. So mod data append to slice. What is data? What is mod data? Sorry? Data is going to be, so our initial Frank, what was it? Frank, it was Frank, Doris, and Beat. What's going to happen? So
Same thing, there will be a compiler because you're appending a string to a slice of persons.
No. Oh yeah, you're correct. Yeah, compile error. Okay. Sorry for that because I copied from code to the slides. No, we want to, but it's a very good point. We would have written person name. Okay, sorry for that. But if it compiled, so what we'd get is actually Frank, new name, Beat. It's the same thing with, we are changing the underlying array. The initial initial slice is still the same, and the initial slice has the information length is 3. So it doesn't care that the array actually holds more values, but this slice still only holds 3 values. And the mod data that is being returned, if it had compiled, is actually longer than the origin. So I think these are caveats where you really have to be very cautious that stick to how you modify your data, and don't trick around with what you're doing. Either copy or modify in place, but don't mix and match, because you're going to have results like that that are totally unexpected. So rules, the behavior of Go is extremely consistent. There's, whenever you wrap your brain around it and think about it, it's actually super consistent. There's nothing that's strange about it. I talked to super advanced Perl developer the other day about this topic, and we actually came to the conclusion that in Perl, although Perl is a very well-defined language and consistent, we actually came to the conclusion that this is more consistent and more you can more count on what's actually happening. And you really need to know the basic data types. So everybody says that read up the language specification, and it's a hard to read document to actually read it correct and reread it and really to parse it correctly, but it is well written. And in corner cases, you can always reference it and use it to actually know what's happening. And always, whenever you call a function, keep in mind, what are you actually passing? Are you passing a value, or are you passing, or you're always passing a value, but is the value a pointer to something, or is it the data itself? And I mean, this is true for all the languages and is a very useful paradigm nowadays. I mean, in JavaScript, we're starting to use Lambda and libraries like that, where you don't ever modify data anymore. You just generate new data and pipe that out to the calling function. And I think this holds true for Go as well. If you want to do something and it's not, performance isn't your biggest issue, and believe me, performance isn't your biggest issue, because your biggest issue is readability and maintainability and bug-free, actually, then don't share too much data. Okay, that's it. Thank you. Easy talk.